Hello, students. We are continuing our study of functions. We're going to do another example today. The main focus of Algebra 1 is functions. There's lots of ways to represent functions. We've seen some of those already. We're going to continue to go through some real-life examples, and you are starting to think about your own function and what that might look like. So here's an example, a real world example that can be represented as a function. And that's any job that pays an hourly rate. So here's a situation. Some kid named Tomiko works at a bicycle shop. What are the variables in this situation? What's the independent variable? What's the dependent variable? And what do we need to know? Yeah, something really important to know is how much money Tomiko makes per hour. So we need to know the hourly rate. And that's a variable, right? That could change over time. In this situation, we're going to say it's 15 bucks an hour. Right? What are the two variables that are in relationship here? Okay, each can represent what? Each stands for hours. So this is going to be the number of hours Tomiko works. Okay, that's one variable. Is that independent or dependent? It's independent. That's the independent variable. And what's the dependent variable? Dependent variable is f of h. Okay, that represents the total amount Tomiko earns. Okay, that's the dependent variable. This is an h, by the way. Okay, so there's lots of ways to talk about this situation. Let's look at some representations. So one of the ways I like to think about functions is with a function machine or function table. So we got h and f of h. So if Tomiko works 1 hour, how much money is she gonna earn? $15. How about 2 hours? $15 an hour, 2 hours is $30. 3 hours of work, $45. 4 hours of work, $60. Okay, so the amount of money earned is dependent on how many hours Tomiko works. So or you could say it's a function. The amount of money earned is a function of how many hours are worked. It's another way to say it. So let's look at this on a graph. And remember, when we draw graphs, it's really important to label our axes. That doesn't mean X and Y. It means with the information that to help us read the graph and make sense of it. So this is going to be H. This represents number of hours. And this represents the function of H. And this represents money earned. You could say total money earned. Okay, for this one, we're probably going to want to have a different scale for our y-axis and our hours axis. So I think it makes sense to go by 1 along here. It kind of depends though. If you wanted to see her like earnings for a week or her earnings for the month, you might want to change the scale here as well. But for right now, I'm just going to go by ones. Now, if you're really lazy, you could go by 15s here, but that's a little sketch. I'm going to go by 10s. 10, 20, 30, 40, 50, 60, 70, 80. Okay. And I need to tell the person reading the graph that this is $10, $20, $30, $40, $50, $60, $70, $80. Okay. So these represent points on the graph. 1 hour of work earns $15. That's what this point on the graph is. 1 hour of work is $15. 2 hours of work, you make 15 for the first hour and 15 for the second hour. So that's $30. 3 hours of work is $45. 4 hours of work is $60, etc. So looks like a very constant rate because the hourly rate is constant at $15 an hour. One thing we like to look at is what happens at 0. If Tamika works 0 hours, how much money is she going to earn? Right, she's going to earn $0. You don't do the work, you don't get paid. Okay, so this point is kind of interesting. In math, we like to know what's happening at 0. Does this graph make sense to connect the dots? Is this discrete or should I continue and fill in this line? Well, it depends on the employer and it depends how the money is calculated. If she gets paid for half an hour, maybe you could fill in the dots right here. Okay. Is she going to get paid for like 3 minutes? Probably not. So in this situation, I am not going to connect the dots. Okay, the domain is limited to whole numbers, so it's not going to get filled in between the whole numbers. All right, we have a table, we have a graph. Anyone want to try for the equation? We have words. So we got 3 representations. Anyone think they know the equation? Yeah. The outcome, f of h, the function of how many hours she works, is equal to 15 times h. Kind of cool? All right, and with function notation, we could say, we could say 3 hours of work is equal to $45. When 3 goes into the function, 45 comes out. This is kind of what it would look like. 1 point in function notation, 3, 45. Looks like that. The 3 represents 3 hours, the 45 represents $45. Okay. So where's the algebra? A lot of kids could figure out how much money you could earn working 5 hours. They would say, okay, how much do you make per hour? $15. And they'd multiply it by 5. Well, 15 times 5 is $75. But an algebra student knows that this simple situation can be modeled with a function. Not only can you find out how much you would earn for 5 hours, you could find out how much you could earn for any number of hours. That's a variable. So instead of saying 5 times 15 is 75, they can model it with the function f of h. H stands for any number of hours that varies. Okay, maybe 1 week you only get 6 hours of work. Maybe 1 week you're working 40 hours. Okay. And they could model it with the function. So they would do 15 times 5. And so for 5 hours of work, when 5 goes into the function, f of 5 equals 75. This is how an algebra student could write the same problem. And they would know that you could put this point on a graph, and they would know that you can make a table of values to show this situation. So in math, we can take real life situations and create mathematical models to represent them.